Hi everyone, welcome to my course in calculus. My name is Karim Abdigilil. I am Egyptian Canadian. So I did my undergraduate in University of Regina with high honors, graduated with high honors. I was doing my thesis on Borzec-Ulam theorem. And after that, I went to do my master's at University of Alberta, and currently I'm pursuing a master's in physics through Open University. So again, thank you for enrolling in my class, and let us get started. All right. So the very thing that we will start with is that we will start with the notion of functions. So a function is a machine that accepts input and produces output. So this course will be mainly semi-rigorous, so it's not going to be at the level of Spivak, but it will be higher than James Stewart and less than like a course in real analysis. So I hope that with this course it provides a foundation for everyone to study real analysis and study like some of the things that might not be very intuitive for people. All right, so let's say so we're gonna start with a notion. In order to make this rigorous, we're gonna start with the notion of sets. So a set is a collection of objects for instance, a set containing the element 1, 2, and 3. So given a set, what you can do is that you can take that set, multiply it by itself or multiply it by other sets. So what do I mean multiply it? Is that I'll let you know in a second. So if B is equal to the set containing the element 1 and 2, then you can produce a set which contains both A and B, so to speak, where you allow repetitions to happen. So it's an efficient way of collecting information about A and B. So A cross B is equal to the set of all tuples A comma B, such that A belongs to A and B belongs to B. So given this information, we can define the notion of a set, the notion of a function. So here, let's say we have a function from A to B. Then a function is a subset. So I'm just gonna denote it by this symbol here. A function is a subset of A cross B. Special subset. So what is that subset? So it's the elements A comma B, such that if there exists B prime for which A and B is equal to A and B prime, then this implies, so where this exists in A cross B, then so if, one second, let me just write it like this. If A and B belongs to sigma of F and A and B prime, belongs to sigma of f, then b is equal to b prime. So, this is a subset of A cross B. So what this means in terms of a machine, this means that whenever you have input, each input have a unique output. So you don't have like two output for the same input. You have different if you have one input, then it should produce one output. It cannot produce two outputs. So that's the notion that is now very well understood. So, I mean, there is one notion that like you might confuse yourself, is that you might have something like this. So you might have 1 going to 1 and 2 going to 2. So this is and 3 going to 2. So this is a function where where there is two inputs that go to the same output. So that is allowed. But whenever you have something where you have something like this, 1 goes to 1 and 1 also goes to 2 and 2 goes to 1, then this is not allowed. The not allowed is the 1 going to 2 and 1 going to 1 at the same time. Each input goes to one unique output. Alright, so now we say that A comma B exist in sigma f, meaning, so that means that we write the following definition. So that definition is like A, f of A is equal to B. Alright, everyone. So yeah, so let's see a couple of things that we could we'll come back to functions, but I wanna like tell you some things that why we study calculus to begin with. So here let's say we want to know at this point, let's say at this point here in green, A. At this point, we would like to know how the function is changing instantaneously at that point. So we can draw a graph right away that barely touches that point. So that will capture how much the function is changing for that particular point. How the function is changing instantaneously, because you captured how it slopes at that particular point. So what we do here is we get let's say we want to capture that point. We want to capture that instantaneous slope at that particular point. Well, we will approximate it. So like calculus in the core is all about approximations at infinity, you could say. So what is this? This is like, let's say we increase A to A plus H. So then if we connect both points, then that gets the average between those 2 points. So let's do that in yellow. 1 second. So this point here, this point here, so something like this. And as you can see, the yellow, as we bring A plus H closer and closer to A, then you can see that the slope, like the instantaneous way of changing the function, is approaching the value of the function at that particular point. So that means that f. So that means that f of a plus h minus f of a over, so that's the slope of the green line, as a plus h minus a. So this is equal to f of a plus h minus f of a over a. So we can see here that the limit gets to approach, so as h approaches 0, as a plus h gets closer and closer to a, we see that things get closer and closer, and at 0 it approaches the value, the instantaneous way of the function is that it's changing at that particular point a. So we get the limit as f a plus h minus f of a over, oh, this should be h, over h. This gets you the slope, the instantaneous slope, and we call that the derivative of the function at the point a. So as you can see here, how is this useful? How is this useful is that we get to use approximations, we get to use linear approximations of things that allow us to calculate things like velocity, allows us to calculate things like many things in physics. I will do a course in physics, and you will see how much are things like changing, and how useful this concept is working, and how much credit we should give to both Leibniz and Isaac Newton for inventing these concepts for us. Alright, so now that that's said and done, next time I will preview what can we do with functions and how we can use functions, and we will have a long journey together to understand and dissect calculus from the point of view of rigorous way to understand things. Okay guys, thank you so much, and I will see you in the next lecture. Bye.